Okay, hello everyone. This is a video for the second part of example 16.5. Okay, in the previous video, we already solved the moment function. Okay, of the beam. Okay, and next we have to use this moment function to calculate the elastic curve or so-called deflection of the beam. Okay, in the final part, we need to use the differential equation. Okay, let me write down the differential equation we are going to use here. It's called EI and second derivative of nu, okay, or mu, equal to m of x. Okay, okay, so the m of x is that's the moment function. Okay, so next time we have to solve this new or mu. Okay, new. Okay, and how to do that? We have to integrate the equation twice. Okay, integrate the equation twice. The equation twice, and both sides. Okay, both sides. Integrate the equation twice, both sides. Okay, so how to do that? Okay, let me write down. Okay, so the ER is a constant, so let's keep it. And you integrate the second derivative of nu, it will become the first derivative of nu. Okay, so it's become first derivative. And then we have to integrate the moment function. Okay, so the moment function integrate this moment function one more time. So how to do that? So this power is 10220. So typical integration rule, right? Okay, so it will become 26 x minus 02 and minus 258 x minus 0 to the 1. So this will be minus 4 over 3 x minus 0 3 plus 3 4 over 3 x minus 5 over 3. The last one is 50 x minus 5 to the power 1. And here we need to put the undetermined constant here called C1. Okay. Okay, after doing integration, you have undetermined constant, right? Okay, but then you may think one problem. Okay, okay. In the last video, when we do the integration of loading function here, when we do the integration of loading function to become a shear force function and integrate the shear force function become a moment function, when we did this integration, we didn't add any undetermined constant. Why? That is because you already solved the undetermined constant. Okay, you already solved the undetermined constant. Okay, actually it is your first step. Okay, to remember the first step, we use the rigid body equilibrium to calculate the reaction force and reaction moment from the support. Actually, this is undetermined constant. You already solved it. Okay, so that's why in this part Wx, V of x, and M of x calculation, double integration, we didn't add any undetermined constant because you already solved it. Okay, but here, you have to add an undetermined constant. Okay, okay, so let's integrate the first time. So we want to solve the mu. Okay, integrate one more time. Integrate one more time. That will become EI is equal to mu equal to 26 over 3 power 3. This 129 power 2. And this will be 3 plus 1 is 4, 12. So 3. So this. So I won't say this calculation is very difficult, but just really take time. Okay, this plus 12, 25. 2. And here we have another undetermined constant. So here C1x, but also another undetermined constant C2. Okay, you have two undetermined constant. And then you all know the differential equation. You want to solve the undetermined constant, you have to use a boundary condition, right? Okay, so how to solve the undetermined C1 and C2? Use the boundary condition. Okay. Okay, so actually you already this is your elastic curve. Sorry. let's solve the C1 and C2 first. Okay, so for the boundary condition, actually for this problem, the boundary condition is easy. Let's just do support. Okay, the support. Okay, in this problem we will only have one support, fixed support. Okay, and so if you look at the PowerPoint, if you have fixed support, what's the boundary condition? Okay, because right now our support is at x is 0 to 0. Okay, so boundary condition. Oh, let me write down the boundary condition. Yeah, because right now our boundary at x is equal to 0. Okay, first of all, the displacement as the support is equal to 0, and since we are fixed support, so actually the slope of the elastic curve at the fixed support x equal to 0 is equal to 0. Okay, so use these two boundary condition to solve the C1 and C2. We use the first. Okay, x is 0, the nu is 0. So that means EI. EI. This is sorry. This should be erased. EI me. Okay, EIB times 0 is equal to, okay, plus x to equal to 0 in this function. Okay, x is equal to 0. X put 0 here, 0. X put it here, 0. Okay, 0. It will become 0 minus 0. And here, plus 0 plus 0. Okay. Okay, here is 0 minus 5, but I say if this bracket is less than 0, okay, less than 0, that means the whole function is 0, right? So this also 0. Here, 25, if you put x equal to 0 in there, minus 5, less than 5, minus 5 less than 0, so the whole function is equal to 0, okay? So it's plus 0 and plus C1, 0 plus C2. Okay, so you will get very easy C2 equal to 0. Okay, the next boundary condition is the first derivative of nu. Actually, first derivative of nu, you already solved it. It's here. So let's do it. So EI dv over dx, x equal to 0. Okay, actually this is 0. Don't forget, this value is 0. Okay, that's why we get this conclusion. And this is 0. This is also 0. Okay. Okay. So that's why it's 20. Here is 26. 26, and put 0 in there. 26 times 0, so it's 0. The next one, 258 times 0. That's 0. Okay, and then plus. This is minus 4 over 3 times 0, so it's also 0. Okay, plus is 4 over 3 times minus 5 power 3, but this is a discontinued function less than 0, so the whole function is also 0. Okay, and plus 50 times 0 minus 5, so this is less than 0 power 1, but it's less than 0, so the whole function is 0, and then plus C1. And so x plus 0 plus C1. Okay, so this also gives you the answer. C1 is equal to 0. Okay, okay, so we know the C1, C2 is 0. Okay, so what's our elastic curve function finally? So our elastic curve function finally is up. So our elastic curve finally is equal to V of x is equal to EI over 1, and that's a lot of bracket. 3x minus 0 power 3 minus 129 x minus 0 power 2, and plus minus 4x minus 0 power 4 power x minus 5 power 4, and plus 25x minus 5, right? Power 2. Okay, power 2, and this is bracket. Okay, this is our elastic curve. That's our elastic curve function or deflection function. is our elastic curve. Okay, we solve this. Yeah, we solve this our elastic curve. But I add the two questions. So we assume if the E is 200 gigapar. Okay, that's a little rollback. Okay, let's roll back. Okay, I assume the E is 200 gigapar in the cross and moment of inertia of the cross section area is 65 times 10 to the power 6 mm power 4. Okay, let's find a displacement at x equals 3, x equal to 8. Okay, okay, okay. So, so for this calculation, I'll just show you what's the importance of a unit. Okay. Okay, so okay, let's see. First of all, let's what the first question is what is mu over 3? Mu of 3. So mu of 3. Okay, just plug x equal to 3 in the elastic curve equation. So EI. So x equals 3. So it's 26 over 3 is 3 plus 193 squared plus minus 1 over 3 is 3 power 4 plus 1 over 3. So 3 minus 5 is equal to 3 minus 5. Okay, 3 minus 5 is equal to minus 2. This is negative. Okay, so this continued function, if your bracket is less than is negative, that means the whole function is 0. Okay. So that means this is 0, okay, and plus, so 3 minus 5 is less than 0, okay, so the whole function is 0, okay, 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 okay. So okay, and then I give you a notice that what's the unit of this? What's the unit of this in this bracket? The unit of in this bracket is kilonewton times meter power 3. Kilonewton times meter power 3. Yeah, in this bracket. Okay, its unit kilonewton times the meter power 3. Okay, and next thing, what is the unit for the E times the moment of inertia? Okay, let's do the calculation. Okay, EI, we assume it's 200 gigapascal and times 65 times 10 to the power 6 m power 4. Okay, let's check the unit. So here G is 10 to the power 9, don't forget. And Newton is Pascal is Newton per meter square. So it's times 65 times 10 to the power 6. So this, don't forget, is minus 3 power 4 and m4. So let's do a little arrangement here. Here will be 20 times 65 times 10 to the power 3 Newton times meter square. So this will lead to 20 times 65 and kilonewton times meter square. Okay, so the unit of E times I, elastic modulus times moment of inertia, its unit is force times area. Okay, so kilonewton times m square. Okay, so we lumped this together. So what is V of 3? V of 3 is equal to, just use your engineering calculator to calculate this bracket, this big bracket. Yeah, I don't want to show the detailed calculation here. In my calculation is minus 954. Oh, it's kilonewton times meter square. And what's the denominator? The denominator is 20 times 65. 20 times 65. Its unit is kilonewton times m square. Sorry, this should be 10 to the power. Sorry, this m is m cubic. Okay. Okay, so after all, you will get the minus 0.07338 m. Okay, this is a deflection at the position 3. And the next one, what's the deflection at the position 8? Deflection at position 8. Okay, so same thing, just the EI, okay, in the bracket. So it will be 26. I should pull this down a little bit. Okay. First of all, it's a to the power 3. The second term is a to the power 2. And this one minus 1, 3 is a to the power 4. And plus, be careful here. So it's x equal to a minus 5 is a minus 5 is 3, so it's 3 to the power 4. Be careful, 3 to the power 4. And the last term is 25, and x equal to a, so a minus 3, a minus 5 is 3, so it is 3 to the power 2. So that's overall. Okay, so the bracket, the unit for the bracket, the same thing here. The unit for the bracket is kilonewton times meter cubic. And so, okay, you just using your engineering calculator to calculate this value. I won't show this calculation again because save some time. So after all, you are equal to, the denominator is 200 times 65 kilonewton times meter squared. And the numerator is, my answer is minus 4932 kilonewton times meter cubic. So after all, you have minus 0.3794 m. Okay, you see this more negative at x equal to 8. Okay, that's very reasonable for the cantilevers. Okay, reasonable for cantilevers. Okay, so so we finish all the calculation here. Yeah. So the calculation, I won't say difficult, but you need to pay attention for lots of things because lots of term, lots of number, and you have to hit your calculator accurately. So yeah, just be careful for every calculation procedure. I won't say it's difficult, but just you need to pay attention a lot. Okay, and don't forget the unit. Unit is very important. And finally, you want to write down the correct answer. Unit is very important. Okay, so I just stopped the video here. We finished the example 16.5. So I think we will I will record other video for the other example next time. So I'll stop the video here. See you next time. Bye bye.